Welcome back to the Deep Dive. Today we're taking a pretty unique approach to getting up to speed on a topic.
We are.
We're forgetting the textbook. Instead, we are diving straight into a stack of high-stakes interview questions for a really specialized, and I mean absolutely critical role, the boiler technician.
That's right, because if you really want a shortcut to understanding a trade, the core physics, the safety demands, and the actual skills needed.
You look at what the top employers are asking.
Exactly. So our mission today for you is to pull out all the key knowledge from these questions to give you a fast but really thorough understanding of this field.
Okay, let's unpack this, starting with the most fundamental principle of how this whole thing even works.
Right. The first question any candidate gets, the first hurdle they have to clear, is explaining the core function of the machine they're supposed to be an expert on.
Makes sense. So we need to know not just that water gets hot, but how that heat becomes, power for our infrastructure.
Right.
So what is the working principle that defines a modern boiler system?
The basic idea, of course, is heating water to make steam. But the real concept here, the science, is thermodynamics, specifically something called latent heat.
Latent heat.
Yeah, you put in energy to get the water to its boiling point, but then you need a huge amount of extra energy, that's the latent heat part, just to force the liquid to turn into a gas, into steam.
And that steam is now under pressure.
Right, and it contains exponentially more stored energy than the hot water ever did. That pressure is where the utility and the danger comes from.
And the energy to do all this. It's not just one source. The material we looked at shows technicians have to master systems that run on natural gas, oil, or electricity. That's a huge range.
Oh, it's a massive range. And they are not the same skill set. If you're on a natural gas system, you're focused on perfect air-to-fuel ratios for clean combustion.
To avoid carbon monoxide.
Oh, precisely. But if you're dealing with heavy oil, now you're worried about viscosity. You might have to preheat the fuel just to get it to flow right. And electricity. Well, it's cleaner on one end, but the electrical loads and safety protocols are a completely different world.
So the technician isn't just a mechanic, they're a combustion expert or a power specialist.
Depending on the day, yes.
So where does all this high-energy steam actually go? What's it used for?
It's doing critical work. The sources point to three main applications. Heating for, huge buildings and complexes, powering engines or turbines to generate electricity, and then other industrial processes.
Like what?
Things like sterilization and food processing, or hospitals, or providing the heat for specific chemical reactions. This technician is managing a piece of core societal infrastructure.
Which definitely raises the stakes.
Yeah.
Okay, so that shifts us from what a boiler does to what the technician has to do. Here's where it gets really interesting. Focusing on maintenance.
Maintenance is everything. It's the real test. It's where theory goes out the window and you find out if someone can actually keep this critical asset running.
And the sources are pretty clear on the experience level. They mention a 5-year benchmark pretty consistently.
That 5-year mark, it suggests they want someone who's seen things go wrong, someone who understands prevention, not just reaction.
So what are those core tasks? It's more than just a quick look around, I assume.
Oh, way more. We're talking detailed routine inspections, actually getting inside pressure vessels, rigorous cleaning of tubes and burners because any buildup kills efficiency, and troubleshooting small stuff, minor leaks, scaling before it becomes a big problem, and then, of course, replacing parts when they fail.
The sources also made a point to distinguish between residential and industrial systems. That seems like a big deal.
It's a different universe. An industrial water tube boiler is it's a beast compared to a residential fire tube system you'd find in a small building.
Because of the pressure.
The pressure, absolutely. We're talking hundreds of PSI, which ramps up the danger and all the regulations you have to follow, like the ASME codes. Plus, you're dealing with complex feedwater chemistry. You have to treat the water to stop mineral buildup or scaling inside the tubes. It's non-negotiable for safety at those pressures.
Okay, speaking of pressure and complexity, let's get into a scenario, the kind of thing that really separates the pros from the amateurs.
The complex repair question. Every good interviewer asks this. They want to see how you handle a system where multiple things have failed at once.
And we found a great anecdote in the source material, a project with 2 simultaneous issues, a failing heat exchanger and clogged burners. Why is that specific combination so bad?
It's a death spiral for the system. Clogged burners mean you're not getting complete combustion, so you get soot, a lot of soot.
Which coats everything.
It coats the heat exchanger tubes, and that soot acts like an insulator, so the heat can't transfer to the water efficiently.
So the system has to work way harder, burn more fuel, and all that trapped heat puts stress on the metal.
Exactly. That's what causes the heat exchanger to fail. It gets stressed, it cracks, it just falls apart. So the solution wasn't just fixing one thing. It was a major operation.
What did they have to do?
They had to coordinate a team to replace that massive heat exchanger, which is a big job.
Yeah.
But at the same time, they had to clean out the burners, figure out why they clogged, and then recalibrate the entire system's air-to-fuel mix when they were done.
The sources said it took a week to finish.
Yeah.
That feels long. Was that a planned shutdown?
Unlikely. Given the nature of the failure, that was almost certainly an emergency shutdown. So the technician isn't just a mechanic at that point.
They're a crisis manager.
They're a crisis manager minimizing millions of dollars in downtime for the client. That is a high-stakes skill.
Which brings us inevitably to safety. That level of responsibility means you have to be absolutely rigid about it. So let's shift to the non-negotiables, the safety and diagnostic protocols.
Safety is paramount. It has to be. You are managing a controlled explosion, essentially. And the protocols go way beyond just wearing a hard hat.
So what's the number one procedure? The first thing you do before you even touch a tool?
Lockout to gout. LTO. It's a procedure to make sure all the energy sources, steam, electricity, fuel, are shut off and physically locked so they can't be turned on by accident.
And for a boiler, that's more complicated than just flipping a breaker.
Much more. You're isolating high-pressure steam valves. There's residual heat, residual pressure. You have to follow a very specific sequence.
What about checks on the boiler itself, the machine's own safety features?
Critical. You have to physically test the relief valves. That is your absolute last line of defense against overpressurization. You check the gauges to make sure they're accurate, and you confirm the emergency fuel shutoffs work instantly.
If a relief valve sticks.
You're operating a potential bomb. It's that simple.
And the personal gear, the PPE. I'm guessing it's more than just work gloves.
Oh, definitely not. You need high-temperature, steam-rated gloves, specialized face shields, flame-resistant clothing. And safety isn't a one-time thing. You have to be doing regular training, regular drills, specifically for steam system failures.
Okay, that's prevention.
Yeah.
What about when something's already gone wrong? How does a technician troubleshoot a problem?
It's a very logical, layered process. You start with the data, you look at the control panel, check for any diagnostic codes, look at the system logs.
And if the codes don't tell you everything?
Then you move to physical checks of the common culprits. But we're not talking about just the thermostat. A pro is checking differential pressure across the tubes to spot clogs. They're testing the water chemistry, they're using a manometer to check the flue gas draft, they're hunting for very specific pressure anomalies.
And if that still doesn't nail it?
Then you go to the book. You consult the boiler's technical manual and run the specific diagnostic tests the manufacturer recommends.
What's fascinating here is, it's this process, right? It's this blend of digital diagnostics from a computer, physical checks on known failure points, and then referencing the documentation.
It's critical thinking under pressure. That's the job.
So beyond the hands-on work, there's the final piece, career development. You can't just learn this stuff once and be done, not with changing tech and regulations.
Impossible. It's a field of constant learning. You have to engage in continuous education. That means attending industry seminars to hear about new regulations, especially for emissions, and getting new certifications.
And reading, right? The sources mentioned professional journals.
Absolutely critical. Journals are where you read about new materials, new maintenance tricks, or analyses of recent accidents. You learn real-world lessons that aren't in the textbook yet.
And it's also about who you know. Networking, online forums.
Yeah, being able to crowdsource a solution to a weird problem you've never seen before from someone halfway across the country, that's invaluable. It's a shared knowledge base.
You know, it's interesting. This role seems to be part of a bigger ecosystem.
It really is. The skills are so transferable.
We saw a bunch of related job titles.
Yeah.
Things like boiler engineer, boiler operator, even boiler fireman.
And those core skills managing, pressure, fluids, combustion, they open doors to other roles. You might become an air compressor engineer or an auxiliary operator in a power plant or a building engineer who's in charge of all the mechanical systems.
And the market seems to recognize that value. The source has even been in career tools like an offer analyzer so you can check if your pay matches the market rate.
It just confirms that this is a recognized high-skill trade that requires you to keep investing in your own expertise.
So to recap, this deep dive has, I think, really quickly covered the core science of latent heat, the kind of coordination you need for a catastrophic failure, and the absolute necessity of safety procedures like LTO.
It means that being a boiler technician is this blend of understanding physics making steam for heating, power, whatever it is, and having this really rigid operational discipline.
And that troubleshooting process is so structured, you go from codes to pressure checks to the manual.
And the safety checks are always number one. Testing the valves, the gauges, the shutoffs. That has to be muscle memory. And the constant learning. Seminars, journals. It shows this is a trade that never sits still.
So what does this all mean?
I think a final thought for you, the listener, is that success here seems to depend on a commitment to external standards, following the rules, like using the right PPE for steam and using the manufacturer's manual, but also going outside your job, to training, to networking. That dedication to standards is what defines a professional in this field.
Yeah, absolutely. And it leaves me with this one last thought. We've established that these techs have to master different fuels, gas, oil, electricity. If there was a huge policy shift and suddenly everything had to run on, say, green hydrogen, what specific new technology for that one fuel would just completely change the safety rulebook for these technicians?
Yeah.
Something to chew on as you connect these very specific job requirements to the much bigger energy picture.